From drawing board to battlefield, creating a military tank is a high-tech marvel. Engineers use AI and 3D modeling to design advanced tanks, while skilled workers and automation bring them to life. The process involves sourcing tough materials, rigorous testing, and complex logistics to ensure each tank is battle-ready. This journey highlights the innovation and expertise that go into making these powerful machines. The intersection of innovation and strategy. Modern tank design is a dynamic field characterized by rapid technological advancements and evolving military strategies. As threats on the battlefield become increasingly sophisticated, tank design must adapt to meet these new challenges. This evolution reflects the broader trends in military technology and strategic needs. Artificial intelligence, AI, in tank design. Artificial intelligence, AI, has revolutionized many fields, and tank design is no exception. AI's ability to process vast amounts of data quickly enables engineers to simulate various battlefield scenarios and evaluate different design options efficiently. For instance, AI can analyze how different armor configurations perform against specific types of ammunition, providing valuable insights that guide the design process. These AI-driven simulations help in predicting how a tank will behave under various combat conditions, allowing designers to optimize the tank's armor, weapon systems, and overall functionality. AI algorithms can also be used to predict potential failure points and suggest design improvements, significantly enhancing the tank's reliability and effectiveness in the field. 3D modeling and simulation. Another transformative technology in tank design is 3D modeling. Traditional blueprints and diagrams, while useful, often fall short in providing a clear, interactive view of complex systems. 3D modeling addresses this by offering a detailed and manipulable representation of the tank. Engineers use 3D models to visualize and modify tank designs in real time. This flexibility is especially valuable during the early stages of development, where changes are more manageable and less costly. For example, if a particular component is found to be too bulky or heavy, adjustments can be made to the 3D model instantly, and the impact of these changes can be assessed immediately. 3D modeling also facilitates better communication among team members and stakeholders by providing a clear and shared understanding of the design. This collaborative approach ensures that all aspects of the tank, from its armor to its electronic systems, are optimized before moving to the physical prototype stage. The role of collaboration. The collaboration between military experts and manufacturers is crucial to the success of tank design. Military experts offer valuable insights into strategic needs and potential threats, ensuring that the tank's design addresses real-world challenges. Manufacturers, on the other hand, bring their expertise in production techniques and practical considerations, ensuring that the designs are not only effective, but also feasible and cost-efficient to produce. Engineer Jacob from a leading defense contractor underscores this point. Our goal is to create a tank that meets battlefield needs, but we also need to ensure it's something we can actually build. That's why we work closely with military experts to understand what the tank needs to do, and then we figure out how to make it happen. This close collaboration helps strike a balance between innovation and practicality, resulting in tanks that are both advanced and producible. Importance of raw materials. The quality of raw materials used in tank production is critical to the tank's performance and durability. Key materials include high-grade steel, advanced composites, and specialized alloys. Each material must meet stringent standards to ensure that the tank can withstand the harsh conditions of combat. High-grade steel. High-quality steel is a fundamental component of tank armor. While steel has been used in tank manufacturing for over a century, today's steel is far more advanced. Modern tanks require steel that is both strong and lightweight, combining durability with mobility. This specialized steel, often referred to as ballistic or armor-grade steel, undergoes a highly controlled production process to ensure it can absorb and deflect the kinetic energy of projectiles, reducing the risk of penetration. The sourcing of this steel involves close collaboration with specialized manufacturers who adhere to strict quality control measures. The steel must undergo rigorous testing, including impact and ballistic tests, to verify its strength and durability. The global supply chain for high-grade steel includes critical suppliers from countries like Sweden, Germany, and the United States. However, geopolitical tensions and trade policy changes can disrupt this supply chain, impacting the availability and cost of these essential materials. Advanced composites. Advanced composites are used alongside steel to create layered armor systems that offer superior protection. Composites are materials made from combining two or more constituent materials with different properties, resulting in a material with characteristics distinct from the individual components. For example, ceramics and polymers can be combined to create a composite that is both lightweight and highly resilient, capable of withstanding significant impact forces. The process of sourcing these composites is complex, involving a global network of suppliers. Manufacturers must ensure that the composites meet specific requirements for tank armor. Quality control is paramount, as any variation in composition or manufacturing can compromise the armor's effectiveness. The supply chain for composites extends across Europe, Asia, and North America, with suppliers working to meet the rigorous standards demanded by military applications. Specialized alloys. Specialized alloys are used in various components of the tank, including the engine, suspension system, and weapon systems. These alloys are designed to offer a balance of strength, flexibility, and resistance to wear and corrosion. They often contain elements such as titanium, tungsten, and molybdenum, each contributing to the material's overall performance. Sourcing these elements can be challenging due to their limited availability and fluctuating market prices. For example, tungsten is primarily sourced from China, which controls a significant portion of the world's supply. This reliance on a single source introduces risks, particularly if geopolitical tensions rise or trade restrictions are imposed. Manufacturers must constantly monitor these risks and develop contingency plans to ensure a continuous supply of materials. This may involve stockpiling essential materials or seeking alternative suppliers in other regions. Integration of automation and skilled labor. Tank assembly is a well-orchestrated process that combines advanced automation with the expertise of skilled workers. The assembly line is designed to ensure that each tank is built to withstand the harshest battlefield conditions. Starting with the chassis. The assembly process begins with the chassis, the tank's structural foundation. Constructed from high-strength steel, the chassis must be both sturdy and flexible to absorb shocks from rough terrain. Large robotic arms handle the heavy steel plates, welding them together with precision. This automation ensures that each weld is consistent, minimizing the risk of weak points that could compromise the tank's integrity. The chassis also includes mounting points for other components, such as the engine, suspension, and tracks. Ensuring these points align correctly is crucial for the tank's overall performance and ease of assembly. Installing the powertrain. Once the chassis is complete, the powertrain is installed. The powertrain consists of the engine, transmission, and drive systems that propel the tank. Modern tanks are equipped with powerful diesel or gas turbine engines capable of generating thousands of horsepower. The installation of these massive engines requires a combination of automated machinery and skilled technicians. Robotic systems lift and position the engine within the chassis, while technicians secure it in place and connect it to the transmission and drive systems. Precision in this installation is vital, as even a slight misalignment could affect the tank's performance. Assembling the suspension and tracks. The next step involves assembling the suspension and track systems. The suspension system includes components like road wheels, torsion bars, and shock absorbers, which work together to provide stability and mobility. The tracks, made from a combination of steel and rubber, are mounted onto the suspension system. These tracks give the tank its ability to move over various surfaces. Integrating electronics and communication systems. As the tank's physical structure takes shape, attention shifts to integrating its electronics and communication systems. Modern tanks are equipped with a range of electronic systems, including navigation, targeting, and communication devices. These systems enable the crew to coordinate with other units, track enemy positions, and engage targets accurately. The installation of these electronics requires careful planning to protect the systems from damage, while ensuring they remain accessible for maintenance. Technicians route wiring and cables through the chassis, connecting sensors, cameras, and displays to the tank's central computer. Automated systems assist with tasks such as wiring connections, performing repetitive tasks with speed and precision. Installing the turret and main weapon system. The turret, which houses the tank's primary weapon system, is mounted onto the chassis next. The turret is equipped with heavy-duty bearings that allow it to rotate smoothly in all directions. Inside the turret, the main gun, typically a large caliber cannon, is installed along with its ammunition handling system. The weapon must be perfectly aligned with the turret's targeting systems to ensure accuracy. A combination of automation and skilled labor is used to position the turret on the chassis. Robotic systems assist with mounting the turret, while technicians secure it and calibrate the targeting systems. Additional weapons, such as machine guns and smoke launchers, may also be installed to provide close-range defense capabilities. Adding armor and protective systems. With the main structure and systems in place, the final steps involve adding additional armor and protective systems. Modern tanks are equipped with advanced composite armor that combines multiple layers of materials, including ceramics and metals, to offer enhanced protection against various threats. This armor is carefully fitted to cover vulnerable areas of the tank. Some tanks also feature active protection systems that can detect and intercept incoming missiles or rockets before they reach the tank. These systems are integrated into the tank's electronics, requiring precise calibration to function effectively, ensuring battlefield readiness. Before a tank is deemed ready for combat, it undergoes a series of rigorous tests designed to simulate the toughest conditions it may encounter on the battlefield. These tests ensure that every aspect of the tank's design and construction meets the highest standards of performance and reliability. Environmental testing. Environmental testing exposes the tank to extreme weather conditions to evaluate its performance in diverse climates. Tanks are placed in temperature-controlled chambers that simulate conditions ranging from intense heat to freezing cold. These tests assess the tank's engine, cooling systems, and electronic components to ensure they can function reliably under extreme temperatures. Additionally, tanks are subjected to humidity tests to evaluate their resistance to corrosion and moisture. This is particularly important for tanks that may operate in tropical or coastal environments where high humidity can lead to accelerated wear and tear. Stress testing. Stress testing involves subjecting the tank to various physical stresses, including live fire exercises and simulated explosive impacts. During these tests, tanks are exposed to high-caliber rounds fired at them from various angles. The goal is to assess the effectiveness of the tank's armor and identify any potential weaknesses. Engineers carefully inspect the tank after each test to identify any breaches or damage. These inspections provide valuable feedback for making design improvements and ensuring that the tank can withstand real combat conditions. Simulated combat scenarios. Simulated combat scenarios involve creating realistic battlefield conditions to test the tank's overall performance. This may include scenarios with explosive impacts, chemical attacks, or electronic warfare. These simulations help evaluate the tank's ability to operate effectively under various combat situations and ensure that its protective systems are functioning correctly. Quality control measures. Quality control is a critical aspect of tank production, ensuring that each tank meets the required standards of performance and safety. Advanced quality control systems, including AI and automated inspection tools, monitor the assembly process in real time. These systems can detect defects or deviations from specifications, allowing for immediate corrective actions. Technicians also perform manual inspections, checking each tank for compliance with design specifications and quality standards. Any issues identified during these inspections are addressed before the tank is cleared for deployment. The challenges of moving tanks. Transporting tanks from the factory to military units involves intricate logistics due to their size, weight, and the need for careful handling. After passing final inspections, tanks must be prepared for transport, which may involve disassembling certain parts to facilitate shipping. Road transport. For road transport, tanks are loaded onto flatbed trucks designed to accommodate their size and weight. The route must be carefully planned to avoid obstacles and ensure safe delivery. Factors such as road conditions, bridge capacities, and traffic regulations must be considered. Rail transport. Rail transport is another common method for moving tanks, particularly over long distances. Specially designed rail cars are used to carry tanks, with secure mounting systems to prevent movement during transit. Rail transport is often preferred for its cost-effectiveness and ability to handle large quantities of tanks. Sea transport. When tanks need to be transported across oceans, cargo ships are used. Sea transport requires additional considerations, such as protecting the tanks from saltwater and environmental damage. Specialized shipping containers and protective coverings are used to safeguard the tanks during transit. Air transport. For rapid deployment, tanks may be transported by air using large military aircraft. Air transport is the fastest method, but is also the most expensive. It requires careful planning to ensure that the aircraft can handle the weight and size of the tanks, and that the tanks are securely loaded and unloaded. Final inspection and distribution. Upon reaching their destination, tanks undergo further inspections to ensure they are in operational condition. Any necessary reassembly is performed, and the tanks are prepared for distribution to military units. Coordination between manufacturers and transport agencies is crucial to ensure timely delivery and readiness. The production of military tanks is a testament to the intersection of advanced technology, skilled craftsmanship, and meticulous logistics. From the initial design phase, driven by innovations such as AI and 3D modeling, to the rigorous testing and quality control measures, each stage of tank production is designed to ensure the highest standards of performance and reliability. The sourcing of materials, the assembly process, and the logistics of transport all play critical roles in the successful production and deployment of tanks. As military technology continues to evolve, so too will the processes and techniques used in tank production, reflecting the ongoing advancements in engineering and manufacturing. The next time you see a tank on the battlefield or in a military parade, remember the complex and sophisticated journey it underwent to get there. It's a remarkable example of how technology, expertise, and logistics come together to create a machine capable of withstanding the rigors of modern warfare. Please leave your thoughts in the comments section, and please don't forget to like, share, and subscribe.